Welcome to this Wise Excel VBA tutorial. This video is going to explain how to use the ASC and Chr functions in your code. So the video is really a discussion about how character codes work in VBA. We're going to start by describing the absolute basics of the ASC and Chr functions, and then we'll have a brief discussion of what ASCII codes are and how you can find out what code corresponds with which character. And we'll end up doing that by writing out our own ASCII reference table using some simple VBA code. We'll have a brief discussion of the various control characters, such as new line characters and tabs, before we move on to the latter half of the video, which will talk about Unicode characters, which essentially provide you with a much wider range of characters to produce than the basic ASCII codes. There's a couple of other functions you'll need to learn about, the ASCW and CHRW functions. Then we'll finish off the video with a couple of practical examples, one of which will help us to separate out the individual characters in a string by the type of character that they are. So quite a few things to do here. Let's get started. We'll start with our fairly standard workbook full of movie data. This is the same list of movie titles we've been using for the last few videos in the series. It is a little bit emptier than the previous videos in the series, though. We've got rid of a whole bunch of extra columns that we simply don't need for this video. We're just going to focus on the film titles. I'll stick a link in the video description so that you can download this file as usual. That might be a temporary file just to begin with, so I might link to an older version of the movie data, which might mean that if you download it in the near future, it comes along with a whole bunch of extra columns that you simply don't need. So if you find that you've got extra columns in the dataset, you can just happily delete all of those. Just highlight all the columns and then you can just right click and delete them all. I'm just going to close down that copy of the workbook. I don't actually need it. I don't need two copies to demonstrate what I'm going to demonstrate here, so I'm going to close that one down without saving it. And then once I've got my basic list full of movie titles, I'm going to head straight to the VB editor, Alt and F11. I've already inserted a quick blank new module here. You can right click and choose Insert Module, of course, to do that. And then we're going to begin with a simple little subroutine simply titled The Basics. And then we'll have a look at what the basics of the ASC and Chr functions actually are. Let's start with the basics of the Asc or ASC function. I'm going to use the immediate window. I'm going to use debug.print to print the results of a call to the Asc function. So I say ASC and then open some parentheses. All the Asc function requires is a single parameter containing a string. Now usually that will just be a single character. You can enter more than one character, but it's fairly pointless doing that. What the Asc function is designed to do is return a number which corresponds to the ASCII code for the character you've entered. So if I were to, for instance, insert a capital letter A inside some double quotes and then close the parentheses and hit enter and then just execute that subroutine, it simply tells me what the ASCII code for that particular character is. As I say, it doesn't matter if you enter more than one character. Whenever you run this one, it only returns the ASCII code for the first character in the sequence. If I take away the capital letter A there and go for B and C, it'll give me 66, and then likewise take away the B, it'll give me 67. This works equally well for punctuation characters and numbers, etc. So if I replace the letter C with, let's say, a space character and then execute that, I'll end up with a number 32. I could replace that with, let's say, I don't know, a percentage symbol and then run that one. I'll end up with another number, 37 in this case. A period or a full stop, likewise, would give me a different character code. Numbers, likewise, work equally well. If I type in the number 5, for example, and run that one, I'll get the number 53. So basically, every character you type in from your keyboard has a corresponding ASCII code. Now the idea behind the Chr function or the Chr function is exactly the opposite of the Asc function. With the Chr function you're required to enter a number, and the number corresponds to the ASCII code for that particular character. So if I say debug.print Chr and then open some parentheses, the idea is that I pass in the ASCII code number and the Chr function prints out the actual character that corresponds to that. So let's just reverse what I've done here. If I entered, the first one that I entered there was the number 65, the capital letter A. So if I type in Chr65 and then make sure that I've clicked to the bottom of the immediate window. In fact, I'm going to just clear the contents of the immediate window, Control A and delete, and then just comment out the Asc function from the top. And if I run that subroutine, I get the letter A. And I can change that to any number, of course. If I change it to the number 66, I'll get the capital letter B. If I change it to the number 32, this won't be particularly obvious, but if I change it to number 32, I'll end up with a space character printed out. You might just about be able to make that out in the immediate window there. I could say number 37 instead, and so on and so on. So all the character codes that I can generate with the ASCII or the Asc function can be entered in the Chr function to return the actual character. At this point, it's probably worthwhile knowing at least a little bit about what range of numbers and characters are available to these two functions. You can find this sort of information fairly easily with a quick Google search, although I've got a couple of basic pages brought up already which I'll show you in just a moment. But if you're looking for references to ASCII characters, then the spelling is ASCII. So if you say ASCII table or ASCII reference, something like that, you'll find all sorts of information about how ASCII codes work. Specifically related to VBA though, we've got a couple of pages hosted on the Microsoft Office Developer Center site. So the character set, the full range of characters you can produce, are numbered from 0 to 255, so of course 256 characters in total. These are broken down into two separate halves, so the first 128 characters is a standard set of characters, which should be the same on every machine you work on basically. So you can see in here we've got the number 65 corresponding to the capital letter A, which is where we started, and then 66 for B, etc. We'll see the number 32 corresponds to a space character, 37 for the percentage symbol, as we looked at just in the first basic example. The second half of the character set, starting at 128 up to 255, the page on the Developer Center site shows you the Windows default values for these, but this second half of the character set can be different depending on your locale and the code page used. So there's a little note down at the bottom saying that this might be different depending on which system you're working in. If you're interested in a little bit more about the history of ASCII and how the background all works, then of course there's a great Wikipedia article that explains all about how ASCII came to be and why it works the way that it does. But what we're interested in at this point is, rather than having to rely on looking up our ASCII tables on a website, I'd like to write some code that will generate our own ASCII tables. So let's head back to the VB editor and we'll look at creating a new simple subroutine that will do exactly that. Let's create a quick subroutine then called something basic like list characters. And all this is going to do, all we really need to make this work, is a loop that will run 256 times between the numbers 0 and 255. So we can declare a basic integer variable to do that, of course. We can say dim I as integer. I want these new tables, or this reference table, to be on a brand new worksheet. So I'm going to say worksheets.add, which will generate a brand new blank sheet. That will automatically make it the active sheet as well. What I can then do is say something basic like for I equals 0 to 255. And if I give myself a couple of blank lines and then say next I to move on to the next iteration of the loop, inside the loop then all I would like to do is populate the cells in columns A and B with both the number, the ASCII number, and the actual character which corresponds to that number. So to make that work, I'm going to use the cells property. I'm going to say cells, and then I'm going to say I plus 1 for the row number. So that will refer to the number contained in the integer variable as I'm processing the loop. So I plus 1 will make the first row number 1, of course, and then the first column will be number 1 as well. And I'm going to set the value of that cell to be equal to the value of the integer variable, the loop counter. Just a quick copy and a paste of that single line, nice and simply, just to cheat, or not cheat, make it more efficient. And we'll say cells I plus 1, 2 is the actual character represented by that number. So I'm going to use the Chr function and then pass in the value of my I variable. So just switching back to Excel temporarily, just to make sure I don't have an extra worksheet, I'm going to create a brand new one. If I now simply run this subroutine, I'll end up with my own basic ASCII table with some useful characters after the first 32. This is where the actual useful printable characters start to appear. We could perform a similar sort of reverse operation to spit out the ASCII codes for each character in a string. If I switch back to sheet number 1, what if we wanted to print out the ASCII codes for every character in a particular string? So let's say you cell A14, for example. If I wanted to do that, I'd head back to the VB editor and then create another new subroutine. Let's call this something like list codes, or list ASCII codes, something like that. And what we're going to do this time is declare another integer variable, which will help us to loop through the items in the string. So I'll say dim I as integer. I'm going to have a string variable that will hold the entire string, so dim S as string. And then just for convenience, I'm going to store the value of that cell in my string variable. I've just given myself a few blank lines so I can bring the code towards the top of the page. So what we can do now at that point is say S equals, and let's just say active cell.value for now, just something nice and convenient and quick and easy. I can then say for I equals, and this time I'm going to loop from the number 1 to the length of the value stored in my string variable. So there's a function called len, which we've used in a couple of the previous videos in this little mini-series. Just for the len of s, I can then say next I, and then inside the loop what I can do is I'm just going to debug.print this rather than write it out to a worksheet, but I can say debug.print, and I want to generate the ASCII character code for the character that I'm currently looking at. So I need to loop over each individual character, of course. So to do that, I can use another function we've used in a recent video. We can use the mid function. So I can find from the middle of my string variable, starting at character position related to the value of my I, my integer variable. I can then return a length of characters that's equal to 1, and then simply debug.print the ASCII value of that character. So if I just clear the contents of the immediate window, and then if I were to run that subroutine, I'll end up with a sequence of characters, or at least a sequence of codes that correspond to the individual characters that make up that string. So far we've dealt pretty much exclusively with the visual printable characters like letters and numbers and punctuation characters, so it's what you're mostly going to be dealing with. If you were to refer back to the character set tables of the first 128 characters, then you'll notice that the first column, pretty much the first 32 characters in that column, pretty much doesn't have any sort of representation whatsoever. You'll see that from your printable version, your custom ASCII table as well, if I scroll up to the top, the first 32 rows have basically either nothing or these kind of placeholder characters. There are some blanks in there as well. Basically what these first 32 characters represent are referred to as control characters, and they have a sort of historical basis in the way ASCII was first developed. And again, if you're really interested in that, the Wikipedia article has a great overview of how that actually works. But many of these control characters in the first 32 positions are basically obsolete anymore. They have no real purpose in modern computing. Some of them, however, are still in use. So let's have a really quick look at some of the basic control characters that you're still likely to see in VBA these days. I'm going to create another quick new subroutine called control characters. And then what we're going to do is have a couple of string variables that will hold two separate words. In fact, let's have a couple of constants rather than variables. I'm not going to change these. It's going to say const s1 as string equals wise, and then const s2 as string equals owl. So it's just slightly easier than writing out separate lines to assign values to those variables. What I'd now like to do is just debug.print a couple of examples of the value of s1 and s2 concatenated with some of the control characters. So let me just clear the contents of the immediate window, and let's start with a really common one. I'm going to say debug.print s1 followed by an ampersand, and then I'm going to use actually two in sequence, chr13 and another ampersand, and chr10, followed by one more ampersand and s2. Now if I were to run that subroutine at this point, I'll end up with wise and owl printed on two separate lines. So chr13 and chr10, and again you may have encountered this in a previous video in this little mini-series, chr13 represents something called a carriage return, and chr10 represents something called a line feed. And again, if you're really interested in the historical basis of that, Wikipedia's got the answer for you. Now we do have modern equivalents of that sort of thing now. Control characters in VBA, the useful ones at least, have constants to represent them, so you don't need to do this yourself. You don't need to remember the character codes for a carriage return and a line feed. What you could do instead is use debug.print, and then rather than saying chr13 and chr10, you could use something called VBCRLF, Visual Basic Carriage Return Line Feed, of course. If I just clear the contents of the immediate window and then just run that subroutine again, I'll end up with two copies, of course, but that will give me wiseowl and wiseowl on separate lines. There are subtle variations of that as well. There's a more modern equivalent of VBCRLF, a sort of system agnostic version of this. Again, if you're reading about how ASCII works and you're reading about carriage returns and line feeds and control characters, you'll understand why there are two separate characters to make this work. Technically, these days, modern systems don't really need both systems, both characters, a carriage return and a line feed. But there's a new constant called VBNewLine, which will use the correct constant, the correct values, depending on which system you're using. So some systems only use a carriage return, some systems only use a line feed, some use both. To make it completely agnostic, you can use VBNewLine. So if I were to, again, clear the contents of the immediate window, and then I were to run that subroutine again, I'll end up with wiseowl, 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 but they're all on separate individual lines. One of the other useful control characters you'll still encounter is the tab character. That corresponds to character or ASCII code number 9. So if I were to copy and paste, let's say, this debug.print line, the first one, and then paste that in, I'm going to replace my Chr 13 and Chr 10 with a Chr 9, and then remove one of the other remaining ones. So it's S1 and Chr 9 and S2. And if I were to execute that one, I'll see that the last line gets printed out with a tab space in between the two words. Again, there's a VB equivalent for Chr 9 with a slightly more convenient way to do this, which is called VB tab, in case you hadn't already guessed that. So if I say VB tab and then once again just run the entire subroutine, I'll get, in fact let me just clear the content of the immediate window and then run that one again, I'll see the last two characters get the tab space in between them. It's important to realise that not every control character gets represented in the same way in every single system. So I'm just going to demonstrate that by adding in a couple of extra lines to do with new line characters. So we looked at VB CRLF and VB new line. I'm just going to add in a couple of extra ones to separate out the carriage return from the line feed. So let me just paste this line in again. And I'm going to go for one line that says VBCR and then another line which just says VBLF. You'll see all these constants, by the way, in the IntelliSense list. If I just delete VBLF and press Control and Space on the keyboard and look for VBCR and then VBLF and VBCRLF, these are all in the IntelliSense list, so you'll be able to find all of these yourself if you need a bit of help remembering what their names are. Anyway, just to clear the contents of the immediate window again, and then if I were to run that subroutine, you'll see that I get all of my wise owls up to the tab characters, up to the last two lines, on separate lines. So every combination of carriage return and line feed, carriage return and line feed, carriage return and line feed, and a separate carriage return, a separate line feed, always put a space, a new line character in the immediate window. But that's not necessarily the case in different systems, and a really quick, simple, easy way to demonstrate that actually would be to just insert a new worksheet actually. So I'm going to say worksheets.add again, and then I'm just going to copy and paste that set of code to down below worksheets.add, and then I'm going to replace the debug.print with a range a1.value. So I can then copy that part and paste it over the top of all the debug.prints. Sorry, this is going to take a little bit of fiddling around to make that work, but it's worthwhile doing, almost, I think, probably. Hopefully you'll feel it's worthwhile doing, and then all we need to do is just change the numbers 2, 3, 4, excuse me, I'll spell 4 properly, 5, 6 and 7. Okay, the whole point of doing all that is to demonstrate that the way that control characters get represented in one system is not necessarily the same as they get represented in another system. So if I were to run this entire subroutine, beg your pardon, I forgot to put in the equal sign next to all of those. I knew I was going to miss something. Let's assign the values to the value property of the cell. Excuse me, sorry about that. And if I were to run the subroutine at that point, I'll end up with the same values printed out into cells in the worksheet. But hopefully you can see there's a bit of a discrepancy between the way certain things are represented. So if you can see, let's have a quick look. It's the fourth one up from the bottom. I've got these two are the tab characters, and you can see there's an issue with the tab characters as well. Those don't represent or don't show a tab space in between the two words. But the fourth one up from the bottom as well doesn't have wise and owl on separate lines. So that one corresponds to just the Visual Basic carriage return. So that doesn't put in a new line character in an Excel worksheet, although it does in the immediate window. So basically this is just to highlight a point that the control characters don't necessarily do exactly what you expect them to do in different systems. The best policy for new lines is always to use VB new line, and that will use the correct combination of control characters for the system in which it's being represented. Now at this stage you may well be thinking that the 256 characters we can produce using the Chr and ASCII functions are a bit limited in terms of the range of characters your computer is capable of producing, and that's absolutely true. But we are limited with these couple of basic functions to that range of numbers. If I tried to say, just use the immediate window very quickly to try to print out a character, if I say Chr 65, of course, that will give me the uppercase letter A, but if I expand my range outside of the range 0 to 255, if I enter a negative number, that will fail. If I try to enter a number greater than 255, that will also fail. So we are really limited with these two functions. However, your computer can produce a much larger range of values, of course. So let's have a quick look back in Excel itself. Let's just do this manually to start with. I'm going to insert a brand new blank worksheet, and then on that sheet I'm going to manually insert a symbol. You can do that using the Insert tab in the ribbon. So if I head to the Insert tab and look for the symbol option at the right hand side, when I've opened up the dialog box, I'm looking at normal text here, so the font that I'm using is just normal text rather than any of the specific fonts. Not every font represents every character or has a representation for every character, so just go with basic normal text. Don't worry about choosing a subset, that will change as I scroll up and down this list, so you'll see as you scroll up and down you change the subset automatically. So you'll see there's a huge range of different characters you can produce. If I scroll down and find an interesting looking character, I had one there, those sort of pool ball type looking things, and numbers in black and white circles, there we go. So if I choose one of those symbols, I've got the number 1 selected there. You can see that I've got a little item here that says Unicode name. Now Unicode is an important idea, which I'll talk about in just a moment. It has a specific character name, dingbat negative circle digit 1, which is a bit of an interesting name. It also has a character code here. Now the number there is 2776. Don't get fooled by this. This isn't actually the character code, the actual number. This is a hexadecimal code for that symbol, but we'll come on to that again shortly. But just bear in mind the word hex here. All I need to do at this point though is just click the insert button, and that will type in that character into that cell. Then I can close down that symbol dialog box and then just hit enter to enter that value. And then what I would like to do is try to print out the ASCII code for that specific character. So to do that, let's just start by heading back to the VB editor, and I'm going to go into the immediate window and type in a quick question mark and try to return the ASCII code for that character. So I'm going to say ASC, open some parentheses, active cell.value, close some parentheses and then press enter. And that tells me that the character in that particular cell has an ASCII code of 63, which is actually a bit of a lie. We know that it's not the number 63. Technically, actually, that character there in that cell doesn't have an ASCII code. It has a Unicode number, but not an ASCII code if you want to get sort of nerdy about these sorts of things. So what the problem with that value there, of course, is the number 63 already represents a character in ASCII. If I look at the sheet 2, where we created our own little reference table, scroll down to find the number 63, and that's actually a representation of the question mark symbol. So back to sheet 4, if I wanted to find out what the actual Unicode number of that character is, then there's a separate function for this. Now it's slightly confusing, I find it slightly weird that they use the function name that they do. It's called ASCW, indicating that it's some kind of ASCII code, but it's technically not. It's a Unicode. The W there stands for wide, as in wide strings. Not that it physically takes up more horizontal space to display it in the worksheet. Not that kind of wide. It's more to do with the amount of memory required to store characters in Unicode. If you're familiar with Microsoft SQL Server, perhaps, then you may be familiar with character data types called char and nchar, or varchar and nvarchar. So the n is short for national character, which refer to Unicode data, and you can only store half as many characters in a Unicode column than you can in a non-Unicode column. So anyway, sorry, that boring little rambling bit aside, ASCW stands for essentially a wide string, which will return the character number, the Unicode character number for that particular character. So hitting enter at the end of that line now will return the number 10102. Now we need to be similarly careful when we try to print the character represented by that specific number. So of course I can't enter a number that's outside the range 0 to 255 with the basic Chr function, but if I look in my IntelliSense list and look for Chrw, there's an equivalent function for using wide strings with the char function as well. So I can say Chrw and then open up some parentheses, and I can pass in that number there, 10102. And then if I close the parentheses there and hit enter, sadly the VB editor prints out a question mark. This is simply because the VB editor isn't capable of displaying Unicode characters. It's just not possible for it to do that. The same thing is true actually if I tried to display that on a message box. If I just take away that question mark there and replace this question mark with a reference to the message box function, I can just hit enter at the end of that line to try to display a message box, and the basic VBA message box can't display Unicode characters either, so that's a bit of a shame. One place that I know that I can display that character is in a cell in a worksheet. So if I just make sure I've got cell A2 selected, and then I'm just going to copy and paste, just to cheat, I'm going to copy and paste active cell.value, paste it over the word message box, put in the equal sign. I'm still slightly embarrassed that I made that mistake earlier on. Don't forget to put in the equal sign, hit enter at that point, and you'll see that the same character gets printed out into the cell. Now, rather than using the actual number of the character in Unicode, you'll often see those numbers replaced with a hexadecimal number instead, as we saw on the insert dialog box just earlier on. You can actually calculate the hex value of a number in VBA using the hex function. If I typed in a question mark and said hex and then opened some parentheses and passed in this decimal number, and then close the parentheses and hit enter. That gives me the hex code 2776, and if you remember from inserting the symbol from the dialog box, that was the exact same hex code that we got from this dialog box when we select that symbol. Each symbol of course will have its own different hex number, and you can see that if you click around there, there's sometimes combinations of letters and numbers. I'm not going to go into how hex works. Again, there's a great Wikipedia article that explains how hexadecimal numbers work, but I'm just going to cancel that dialog box again and then just click away from that cell. What I could do here, if I wanted to print out that character into another cell, let's select cell A3 in fact this time, I could either paste in the hex function, so I could say give me the wide character for the hex version of 10102, or even more usefully, just type in an ampersand followed by an H to indicate that it's a hex number, then 2776, which is the actual hexadecimal number. So I can get rid of all the other bits of code there, just click at the end of that line and press enter, and the exact same character gets printed out again. Just to give you at least one small practical example of where this sort of stuff can come in handy, I'm going to switch into Microsoft Word temporarily just to demonstrate an actual real-life case of where I was using Unicode characters and hex codes recently. So when we run our actual live training courses, the classroom-based training courses, we always produce training manuals, of course. So we produce a physical book which we give to delegates on the course. I'm not trying to encourage you to buy a training course, by the way, don't worry. I'm just explaining why I'm showing you this example. And in those manuals we try to present keyboard shortcuts, as you'd imagine. So when we're writing our documents, we want to present sort of text formatted as a key. So if I wanted to produce a key that showed perhaps an arrow pointing to the right, there's no simple easy way to type that character code in on the keyboard. So what we did was we produced a bit of VBA code that will insert it for us. So what we have here is a quick little button on my little toolbar. I can choose from a list of predefined options, or I could even just type in some characters there that will be formatted automatically. But the ones that work with the arrows, the arrow symbols, things that I can't manually type in on the keyboard, if I choose right arrow I can click OK and it will insert that text formatted as kind of like a key on the keyboard, so I can then just carry on typing. So that's something that we did recently in Word VBA, as it turns out. Word VBA is incredibly similar to Excel VBA. It's exactly the same syntax and grammar, it's just the vocabulary that's different. So I've got a simple little user form in here which I could view the code of, and somewhere in here will be some code that inserts, there we go, look, so we're using CHRW to insert the character codes for the various arrows. That's one that I've just used there, so hex code H2192. And if I were to just maybe in fact just copy and paste that into my Excel VB editor, I will be able to see that if I display the worksheet and then just execute that code by hitting enter, it prints out the right arrow into the cell as well. So there you go. I appreciate that we've done quite a lot of theory-based stuff in this video so far, so just one small practical example of where this sort of stuff comes in handy. I guess at this point a fairly obvious question would be, well, now that I know I can generate Unicode characters, what range of characters can I produce? What's the actual range of values? It's significantly more than 0 to 255. Again, there's a useful Wikipedia article that explains how many characters Unicode can produce. There's over 128,000 at the moment, which is significantly more, as you'd agree, than 256. So let's have a quick little subroutine that's going to write out all the Unicode characters into a new worksheet in the workbook. I'm going to create a new subroutine just down below the last one that I've written to say, I don't know, list Unicode characters. And then what we'll do in here is we'll have another variable. I'm going to call this one n as long, and then I'm going to set, because I'm going to be changing lots of cell values in one procedure, I'm going to change my screen updating settings. So I'm going to say application.screenUpdating equals false. So that'll stop the screen updating when I run this one. Then I'm going to say worksheets.add to produce a brand new blank worksheet. And then I'm going to say for n equals, and then the minimum number I can produce is minus 32,768. And the maximum number I can loop to is 65,535. So that's the range of numbers. If you try to produce a number outside that range, it will all fail, just like the original Chr function did, as I was showing you. Let's say next n, and then we can print out a few different things actually. What I'm going to do is I'm going to say cells. So I want to refer to cells, basically row number 1. I want to produce the row number 1 for this first value. So to make that work, I can say n plus 32,769. So that will equate to the number row number 1 for the first time round, then row number 2 for the second, and so on and so on. I'm going to print this first thing into column 1, so I'm going to say comma 1 dot value equals, again not forgetting my equal sign, and then CHRW, open some parentheses, and then the letter N. So that will print out the actual character, the actual Unicode character. I also want to print out the actual number, so the index number of the character next to that, so I'm just going to copy that line and paste it in, and then I'm going to change that so it's column number 2, and then I'm just going to print out the value of N. And then I'm going to paste it in one more time, and just for reference, because it's sometimes handy to have, you often find Unicode characters defined with their hex codes rather than the decimal number. So let's have the hex function to demonstrate or to print out the hex value as well, just so we've got that for reference too. Right at the end, I'm just going to make sure I've got my screen updating switch back on again, and then we can happily run that subroutine. And if I just make sure I can see Excel in the background, run that subroutine, and eventually it'll take a little bit of time to run, but eventually I'll end up with still running, still running, still running. There we go. I've got a full list of Unicode characters printed out in my worksheet. So what do I get up to? About 98,000 rows down. There we go. So as you'd agree, significantly more than just those original 255 characters. Hopefully you'll find some use for at least one of those characters in that list. Feel free to have a bit of a trawl through, it might take you a bit of time. Just before we move on to the last example in the video, I did want to mention one other potential use for these character codes. It's actually a little bit out of date these days now. If you're still working in Excel 2007 or earlier, then this might still be relevant. But there's a little system that you can find this sort of code on all sorts of different sites. But basically it's a little system that allows you to crack or find a backdoor password to Excel worksheet passwords. And the way that it worked was that whatever password you typed in, there's a nice little website here that describes it in reasonable detail. Whatever password you typed in was converted into a sort of a backup password that consisted of a sequence of uppercase A and B characters, followed by any other character in the range 32 to 255 from the ASCII character set. So what was a really basic brute force approach to crack the password was to loop over all the possible combinations of A's and B's and any other character. So there's a little, there it is, it's a little bit messy looking because it's not been formatted particularly well, but you can see we've got a whole bunch of different integer variables here, and then a whole bunch of for next loops just looping through the numbers 65 to 66, which, as of course we now well know, if we looked back at sheet 2, is 65 to 66 is uppercase A and B. Then the very last loop in that little section there looped from 32 to 126 in that case, and it just sort of a brute force approach and concatenated all the characters together and tried to apply that as a password to the worksheet. Sadly, Microsoft beefed up the, well, not sadly, unfortunately Microsoft beefed up the security, although it's still not the most robust system in the world. So that sort of technique doesn't work if you're working in Excel 2010 or later anymore. But anyway, I just thought that was worth one other example, worth showing you one other example of where the character function comes in handy. The next thing I'd like to do is create a slightly longer example that actually manipulates the original movie data that we have in our list here on sheet 1. So what I'd like to be able to do, and I'm not sure this is a particularly practical example, but it's a nice sort of demonstration of what information you can get now you know how the character systems work, ASCII and Unicode. What we're going to do is we're going to generate some basic statistics about each individual film title. We're going to work out, for instance, how many capital letters, how many uppercase letters there are, how many lowercase letters there are, perhaps how many Unicode characters are in the string. There shouldn't be any for this list, actually. There shouldn't be any Unicode characters, but we can still test for that. We can check how many actual numeric digits are in the string, and then other characters like punctuation we can group together as well. So what I'm actually going to do to start with is just create a few extra column headings across the top row. So in column B I'm going to put in the word Unicode. So this will store the number of Unicode characters in the string. Then I'm going to have uppercase, and then lowercase, and then numbers, and then finally other. So those will be my 5 categories of characters. Just a quick little bit of format painting. I can't resist doing formatting. I won't sleep tonight unless I format those cells in the same way, and then maybe they'll require a little bit of resizing as well so I can actually read those titles. Okay, and then what we're going to do is we're going to produce a system that will loop through this entire list of film titles. There's about 1,200 films in there, and it's going to pick apart the title into its individual characters and work out how many of each type of character there are. Okay, so the next step is to head back to the VB editor, and I think we'll create a separate module for this. We're going to have a variety of different routines in here to build this up, or at least 2 different routines. So let's insert a new module, and then the top of this module, what I'm going to do before I declare my subroutines is I'm going to declare something called an enumeration. Now this is something we've covered in previous videos, and we have a separate video that's part of this main series about how enumerations work. But essentially, to make my life as easy as possible in terms of accumulating the numbers of different characters, I want a quick, simple way to reference the character types. So what I'm going to do is declare an enumeration with the word enum, and then I'm going to call my enumeration something simple like char type. What I can do in there, if I just end the enum, is list out the individual types of values I might want to refer to. So I'm going to refer to my first one's going to be called Unicode. I'm going to assign manually. I don't need to do this because this will be the default anyway, but just to make it clearer what I'm doing, I'm going to say Unicode equals 0. So every item in an enumeration actually holds an underlying value. So basically you're declaring constants. I could do exactly the same thing here by saying const Unicode as long, which is the data type for every value in an enumeration, equals 0, and then const the next one, and so on. So I could do it in two ways. I could declare them individually like so, but it's much more convenient to group them together in this enumeration. So Unicode equals 0, then I'm going to have one called uppercase equals 1, and then lowercase equals 2, and then number equals 3, and then finally other equals 4. Now I've tried to make sure that I did that in exactly the same order that I listed out the columns, so I'm going to take a slightly low-tech approach to making sure I've got the order of these items correct. Anyway, having done that, what I can now do is begin my main subroutine, which is going to be called something basic like listing character types. The first thing I'd like to do inside this subroutine is set up the core loop that will process the entire list of film names from cell A2 down to the end of the list. There are many different ways we could achieve that, many different types of loops we could write, but I'm going to use a technique that makes my life a little bit easier later on in this procedure. So I'm going to start by declaring a couple of basic variables. First of all, dim r as range, then I'm going to declare dim n as long, and on the same line, I could do it on a separate line, but the same line makes sense, n rows as long. The way that I'm going to set this up now is I'm going to make sure that I've got sheet 1 selected. So let's say sheet1.select to make sure I'm there. And then what I can do is I can say set r equals. So I want to basically store a reference to the entire range of cells from A2 down to the end of the list. So I can say range A2, comma, range A1, dot end, XL down. The sort of things we've done many times in previous videos. Again, this always assumes that my list is complete with no gaps, otherwise I'm going to run into problems, but I know that my list is complete with no gaps in it, so I'm confident that that's going to work. What I'd then like to do is store the number of rows in that range in my n rows variable. So I'm going to say n rows equals r.rows.count, nice and simply. And then to set up my basic loop, all I need to do here is say for n equals 1 to n rows. Couple of blank lines, and then say next n. Now that's not necessarily the most straightforward way to process that range of cells, but it is the most convenient for what I want to do inside this loop. The first thing I'd like to do inside the loop is store the film's name in a string variable, and then I'd like to loop over the individual characters in that string. So to make that work, I'm going to declare another variable first, of course. I'm going to say dim s as string. And then I'm also going to declare another variable that can keep track of numbers, so another loop counter type variable. So let's say dim, I'm going to call this one I as integer. I'm pretty confident that none of my strings are more than 32,767 characters long, so I'm safe with an integer for this particular loop. So inside my main loop, I can then say s equals, then I'm going to refer to r.cells, open some parentheses, n, comma, 1. So that will refer to the first row of the range of cells I've stored in my r variable and the first column, and then I can make sure that I say dot value there to read the value of that cell into the string, and then I can write another loop that will loop through each individual character. So I can say for that I can say for I equals 1 to len of s, couple of blank lines, and then say next I. Now I'm at the point where I can start to calculate what type of character it is I'm looking at. So to do that, I'm going to separate this part out into another function. So let's declare a new function down below my n sub. I'm going to say function, and I'm going to call this one character type. This is going to accept a single parameter which will be called character as string. So I'm going to say character, as string, and then the data type that this one is going to return isn't one of our established data types. The data type I want it to return is a value from my enumeration called char type. So at the end of the function's definition I can simply say as char type. So you'll see not chart type, which could be confusing, but char type as in character type. Okay, so char type, and if I hit enter at that point I'll get my end function entered in there. Let me just give myself a few more blank lines to bring this up so it's a little more readable. There's a couple of different ways I could do this now. I think the most simple way to do this would be to use a case statement, a select case statement inside my function. So I'm simply going to say select case, then I want to return the Unicode code for the characters, not just the ASCII code. I might have Unicode characters stored in the film's name. So I'm going to use ASCW, ASCW, open some parentheses. I can't remember if I mentioned earlier on that the first 128 characters of ASCW of Unicode is the same as the ASCII characters, so we can use this safely for both normal characters and Unicode characters. What I can then do is say character, that's the value passed in from that parameter there, and then a couple of blank lines and say end select. The cases I want to test for now, first of all, I know that I'm looking at a Unicode character if the number is either less than 0 or greater than 255. So I can write a quick case is less than 0, and then I could simply say character type equals, and the beauty of having used my enumeration as the return type is that I can simply select it from this list nice and conveniently, and that will return the number 0 for Unicode because that's the value that I assigned to it. I can then say case is greater than 255, and then I can say again character type equals, and that will again be Unicode. The remaining ones now, this is the beauty of using a case statement for this. I know that if I were to refer back to sheet 2 again, for example, if I were to look for the range of numbers, numbers come in between character number or Unicode number 48 to 57. So to test for that range I can say case 48 to 57, nice and simply. That's why I use the case statement rather than an if-else if for this particular example. If that's true, then the character type is equal to, and then again I get the choice of number there. Similarly, I can say case 65 to 90. Those are the capital letters. When that's true, then character type equals uppercase, and then another couple to go. Case 97 to 122, those are the lowercase characters, so character type equals lowercase, nearly there, and finally for anything else I can say case else character type equals other, and that's the basics of that function written. Okay, so the next job is to return back to the main routine, and inside this little loop that's looping through the individual characters, I would like to return the character type. I'm going to store that in another variable, so again towards the top of the subroutine I'm going to declare a new variable. I'm going to call it simply ct as char type, so I'm going to use that exact same enumeration that I created earlier on, and then inside the loop, inside the subloop here, looping over the characters, I can say ct equals, I'll just ignore the IntelliSense list there just by pressing escape on the keyboard, and then I can look for my character type function. So I can say character type, let's get rid of that, character type, I'll get there eventually, open up some parentheses, and then the value that I would like to pass in, again, as I did earlier on, I'm going to use the mid function to return the character from my complete string, starting at position number I, and then returning a length of 1. Just to demonstrate that that's definitely going to work, I'm going to use a basic debug.print at that stage and say debug.print ct. I'm going to clear the contents of the immediate window at that point and delete all of that. And then just stepping through this routine, I'm going to set a quick breakpoint on this line here. So I can do that either by clicking onto the line and pressing F9, or just clicking into the grey bar at the left hand side to switch my breakpoint on and off. If I then hit the play button or the run button or press F5 on the keyboard, that will run all the way up to the start of that line. So I've currently got the word Jurassic Park stored in my string. If I now begin using the F8 key to begin stepping through, I'm going to call my function and I'm going to pass in the character J. So that's going to determine that hopefully character J is not a number, not a Unicode character, but it will be an uppercase character. So that's the end of that function, and that returns in debug.prints the number 1. Number 1 is the value that underlies the word uppercase in my enumeration. So enumerations don't store the actual name of the constant, it's the value that we've assigned to it. So carrying on, we can find the next character, which would be the letter U in this case, and then in the case statement we should find that this one is a lowercase value, so that should return the number 2 because that's lowercase. So that looks like that's working. I don't want to go through the entire rest of the procedure at this point, so I'm just going to hit the reset button at that stage and then stop or reset my breakpoint, turn that off, clear the contents of the immediate window and shrink things back down a little bit just before we move on to the next kind of main important part of this entire process. Okay, so we've got the core logic of our procedure working now at this point. The last remaining step is to get the information that we produce written out into the worksheet. Now we have a couple of approaches to doing that. I guess one fairly bog standard way to do this would be using offsets to refer to the correct cell based on the value of the CT, remembering that the CT holds the numbers 0, 1, 2, 3 and 4. So we could offset using that number and then increment the value of that cell each time we encounter a character of that type. That would work reasonably well. It wouldn't be too difficult to write the code to achieve that either. Certainly using our CT variable, which simply holds the number of columns to offset. We need to increment it by 1 actually because Unicode holds 0 rather than 1. But what I'm going to do instead, the problem with using that technique is if you're changing lots of individual cells one by one across the entire procedure, that becomes incredibly slow. So what we're going to do instead is we're going to create an array, and the array is going to essentially hold a range of values equal to the size of this empty table, and then we're going to modify values stored in the array and spit out the contents of the entire array in one go right at the end of the procedure. So that's the approach we're going to take. To achieve that, of course, we'll need to head back to the VB editor, and we're going to start by declaring an empty array in our main subroutine. So below CT as char type, we're going to say dim. I'm just going to call my array ARR, and then open and close some parentheses to indicate that it's an array. That's not actually absolutely necessary, but I always do that to indicate my empty arrays from my variant variables. So having done that, the next thing I need to do is redimension my array to have the correct number of rows and columns. The idea behind this is I might not necessarily know how many rows I'm going to process, so I'm declaring an empty array with 0 dimensions to begin with, so that I can redimension it once I've worked out how many rows I'm using. So after I've calculated n rows, I'm going to say redim ARR, and then open some parentheses and say 1, 2, n rows, comma, 0, 2, 4. So I've got 2 dimensions in that array. The first dimension, of course, represents the number of rows I'm processing. The second dimension represents the number of columns, so those 5 columns. Now notice I've used 0 to 4 here, corresponding to the values I've assigned to my individual items or elements of my enumeration, and corresponding to the order I've listed the columns. Everything's kind of tied in this system. Change one thing and the whole thing falls over basically. So going back to the VB editor, now that I've got my array declared and dimensioned, what I can now do is start populating it using this basic inner loop to loop over the individual characters. So rather than saying debug.print ct, let's just comment that line out. I'll keep that in there for reference, comment it out for now. What I'm going to do now is I'm going to say ARR, open some parentheses. I'd like to refer to the row number that I'm currently looking at. So setting the element of the first dimension, I'm going to use my variable n to do that. The column that I'm going to change, so the element of the second dimension, is going to be determined by the value returned by my character type function, so ct. So array n, ct equals array n, ct plus 1. So that will simply increment that particular value at that particular element of the array. Now that will just carry on being populated for every individual character for each field name, and then for every individual row using the outer loop. So at the end of that loop, what I will end up with is a single array populated with all of the final answers. What I now need to do is write that information out into the correct range of cells. There's a couple of different ways I could use to achieve that, depending on whether I know where the range sits or where it starts. But what I'm going to do here is I'm going to use the value that I stored, or the reference that I stored in my r variable earlier on. I'm going to start by saying r.offset and then open up some parentheses and say 0, 1. So that will shift the entire range of cells across by 1 column to the right. Then I'm going to resize that range by saying .resize, and I'm going to set the number of rows to be equal to n rows, followed by a comma, and the number of columns to be equal to 5. That's equivalent to the number of elements in the second dimension, that's 0 to 4, so there are 5 elements. Close a parentheses there, and then simply assign the entire array to that resized block of cells. Much easier, much more convenient than writing out values and changing values to cells individually multiple times. Okay, so we're basically at the point where we're ready to give this one a quick test. There's no need to set screen updating to false because, well, nothing is visually going to change up until this very last single instruction. That's the only point at which data will get read out into the cells. So, just to reassure ourselves that that block of cells is currently empty, if I were to head back to the VB editor and then just run the main routine, it won't take too long at all. It's done instantly, pretty much. That's for 1200 rows, and you can imagine how many characters there are over all of those 1200 rows, individually calculating the character type for each one. How quick was that? That's fantastic. Arrays make life so much quicker in VBA. So anyway, enough congratulating myself about how quickly that one runs. Let's have a quick look down. So you can hopefully see, you're welcome to check this, by the way, that all the characters are being calculated correctly. So we're getting combinations of uppercase letters and lowercase letters, other, which will basically correspond to punctuation characters in the main. So you'll see some films don't have any other in the other category because things like Transformers don't simply have any punctuation characters. Some films in the list, if I scroll down far enough, there's one, the film 300 is comprised purely of numeric characters, so you can see that that's worked there as well. So yeah, not too shabby a routine. I'm not sure whether that's incredibly practically useful in the real world. I did see a recent example actually of a slight variation on this theme, which was interested in interrogating Japanese script, where there are different character sets in place. So they have, if I get this correct, they have something called katakana, hiragana, and kanji characters. So katakana and hiragana are the two kind of equivalents of the alphabet. They actually have different symbols representing the same sounds, actual individual letters that can be used to make up an individual word. And then the kanji characters are sort of more like, I guess, like pictographs. So an individual kanji character represents an actual thing or a concept. So I believe some of these, and I apologise if I get this wrong in any way, I'm no expert by any means, but many of these Unicode characters here are kanji characters. The more complex ones are the kanji characters, I believe. And then there are also a mix of katakana and hiragana characters in there. So in a similar way to the way that we've separated out our uppercase and lowercase letters and numbers, the example that I saw separated out the kana characters from the kanji characters, and so there are practical implications for this sort of thing. I'm just not sure whether you will find a use for it in your own particular work. But anyway, at least you now know a lot more about how characters work in VBA. You know about ASCII, you know about Unicode, you know about wide strings, you know about how to produce hex numbers, and how to produce basically pretty much any character your computer can reproduce and display in your Excel workbooks. So hopefully you found at least some of that useful and maybe a little bit fun as well. Thanks for watching, see you next time. If you like what you've seen here, why not head over to the WiseOwl website, where you can find loads more free resources, including these videos, some written blogs and tutorials, and even some exercises that you can download to practice your skills. Thanks for watching, see you next time.